Hope you all people drawn this diagram also. Is it yes, guys? Please respond, Shakti. So now,
Yes, sir.
notice it here. So when he is passing an alpha particle or is a fast moving particles through this almost 1,000 atoms of gold foil, almost 1,000 atoms of what? A gold foil. Then he noticed it. So most of the alpha particles are passing straight, means they are crossing the gold foil and they are coming outside, because actually what they think, gold foil, if they'll strike it they should come back, but they are not coming back, they all are passing through that. So from that he has been concluded that most of the, what is the first thing he has been concluded, the first point, Rutherford atomic model. What is the first point from this experiment only we have to say? So what is the first point he has been made? Most of the alpha particles are passing straight. So that he has been said, what he said? The entire,
Have large.
yes. So the nucleus is complete, sorry, the atom having more empty space. That is what he has been said. So most of the atom having empty space, because most of them they are going straight without any deviations. That is what he used to say. It is having, atom contains lot of empty space. So that is the first thing. Next one, he has been said, so only, what is the second one? Only less percentage of alpha particles, very low percentage of alpha particles, they are showing some deflection, and some are showing a little bit large deflection, and very few are turning back into the same direction. So now from that he has been concluded that only at the center point where the deflection is taking place, because we are sending positive charge only, yes or no? So that is what he said, at extremely a small particle, is a small part which is present inside the atom, that is what he used to called as, what he called, what is that called as? That is what he used to call as
Nucleus.
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 So he said that an atom consists of a positively charged and dense and very small, containing all the protons and neutrons, and this positive charge where these neutrons having no charge. So almost the entire mass of the atom is concentrated in where, guys? Entire mass of the atom is concentrated in the nucleus. That is what he has been said. That is the first and the second point. So on the basis of alpha particle scattering experiment, the Rutherford gave a nuclear model of the atom. That is the first thing. Most of the light rays are passing straight. That is the observation he has been made. And from that he can say one point. What is that point? The atom is having, most of the atom is having empty space. So that is why most of the alpha particles are moving straight line. So next one. So as we know, the atom consists of very positively charged, and only they are showing less deviations. Few alpha particles are showing minimum deviation, few are showing little bit maximum deviation, and very few alpha particles are completely rebound or hitting the gold foil, and they're turning back on their path. Is it yes or no, guys? Like rebound.
Yes, sir.
So that is what the four things he has been observed. So the observations made by Rutherford in exam, they will ask you. Then you have to say, first thing what? Most of the light rays, most of the alpha particles are passing the, what it is? They are passing the what? They are passing
Gold
the
foil
without any deflection. Next, second one, the few alpha particles deflected through the small angles, and few alpha particles are deflected through the large angles. Understand, everyone? And the third point is what? A very few alpha particles only showing the rebouncing. Understand? They are turning back on the path back. That is what he has been observed from the gold foil experiment, Rutherford alpha particle experiment, or we can say gold foil experiment. Yes or no, guys? So now from this only he said that Rutherford explained these observations, how he has been explained. So most of the light rays are going without any deflection. So it shows that lot of empty space in the atom. That is the first conclusion he has been made. Yes or no, guys? Please respond.
Yes, sir.
Yes. So now in exam, they will ask you, what is the conclusions made by the Rutherford? Or else they will ask you, what is Rutherford model of the atom? Then you have to say, what is the first point? The most of the atom is empty space. Because why? Most of the light rays, alpha particles are going straight line without any deviation. So from that, we can say it is what, guys? It is most of the atom is empty space. Now, what is the second explanation he has been given? Getting small deviation, and as well as few alpha particles are showing more deviation. That is what he has been given. So the explanation he has been given what? So we know that similar charges will repel each other. So what is the charges we people are sending, guys? Shakti, Sai?
Positive charge.
Sending already sending positive charge only. So as we know, positive we used to call it as like charges, or negative we used to call it as unlike charges. Sorry, like charges only. So both they will show what? If the same kind of charges you used to bring, they will show repulsion or attraction. They will show repulsion. So that is why very few alpha particles are showing minimum deviation, small deflection, and few are showing large deflection. That is also very few. That is what from this he concluded. Somewhere in the middle of the atom, some positive charge is present. That is what he has called. It is extremely small, and they are deviating, deflecting through the small and large angles. So it will show that a center of positive charge is present in the atom, which repels the positively charged alpha particles, and they will deflect them from their original path. So why they are deflecting? Because it is also positive charge, so that it will show the reflection. Sorry, it will show the deflection. So that is only called as the center of positive charge only. It is to called as what, guys? Nucleus. What is to call?
Nucleus.
What is to call?
Nucleus.
Because there only it is showing the deflection. Okay, so now after the third observation, what has been made? Very few alpha particles are completely rebound on hitting the gold foil. So it will shows that nucleus is what? Very dense, and as well as what? It is very hard, which does not allow the alpha particle to pass through that. So from that, he can conclude that the nucleus, or else the center of positivity which is present inside the atom is very, very strong, or it has been said that it is dense and as well as strong. So which is not allowing the alpha particles to pass through that, and it is showing repulsion. So that is why he said that it is having a what charge? A nucleus is having a positive charge. Okay, that is what. So this positive charge, later we have been found that the nucleus is having what? Both protons and as well as neutrons. So as we know, protons is having positive charge, neutrons is having no charge. So that is why the overall charge is positive. So that is why the charge of nucleus is what, guys? The nucleus is positive charge. That is what he has been made. And you can see, so this is all about the explanation for his observations. Now, from this, he has been finally made some conclusions. The conclusions made by Rutherford. That is what we people used to call as Rutherford model of the atom. What we used to call? Rutherford model of the atom. So now if you notice it here, so as we know, what you people understand from the Rutherford observations and explanation? Can you say about the nucleus? Nucleus. What is the nucleus? It is positively charged one.
Very dense and hard.
Very dense and hard.
And the next one is what? The nucleus of extremely small as compared to the size of the atom as a whole. It is how many times it is smaller? Around 10 power 5 times. Yes, it is a 10 power 5 times smaller than the size of the atom. Did you understand, everyone? That is what the nucleus. So these are the three conclusions which we can come from the Rutherford experiment, gold foil experiment. So one is nucleus is present extremely small, that is around 10 power 5 times smaller than the size of the atom. And the next one, it is a positively charged one, and it is what? very high, denser, and as well as very strong. That is what we people can conclude it. Is it yes or no, guys? This is what we called as Rutherford alpha particle experiment or gold foil experiment, we can say. So now, why he is taking alpha particle? They will ask. Then what people will say? Because alpha particles will move
So they're capable to
faster, understanding, and they can penetrate little deeper inside where inside the surface. That is why we people are taking alpha particle. They can penetrate inside the atom up to some extent. So that is why we are taking alpha particles. Is it okay, guys? Please respond, everybody.
sir.
This is the diagram you have to remember, and you have to draw it also in exam, because in the chapter the most important, the atomic theory, is Rutherford's only. Because first one, J.J. Thomson atomic model is nothing correct, only 2 parts it is, and also it is very simple also. Yes or no, Jayvarshini? So now, but this Rutherford only, he has given explanation for the conclusions made by what is that first one, Thomson model, but still he is having also some drawbacks. First of all, we'll study what is this Rutherford model of the atom, what is the conclusions made by him, and later we will study what is the drawbacks of Rutherford model of the atom. Okay. So now, first of all of you keep reading Rutherford's model of the atom. Rutherford's model of the atom. So what is the Rutherford model of the atom? Can anyone say? It's very simple. You can keep reading Rutherford model of the atom. And first point, what is the first point, guys? So atom consists of what charge? It consists of positively dense and small nucleus containing all the protons and neutrons. So from that we can say, what is where the entire mass of the atom is located? Where is the
Nucleus.
located? The entire mass of the atom is located at the nucleus only. So these are the 5 points which you people need to write whenever they will ask you, write the Rutherford atomic model, then you have to write these 5 points. So the first point is what? An atom consists of a positively charged, dense and very small nucleus containing all the protons and neutrons. So as we know, almost the entire mass of an atom is concentrated in the where, guys? Nucleus only. Why it is? Because we know that mass of electron is neglected. Yes or no? Mass of electron is neglected because mass of one proton, mass of one electron, which is how many times? 1840 times it is smaller than mass of proton. Yes or no, guys? 1 by 1840. So that is why the mass of electron is invalid, or we can say negligible mass. So that is what we can say. The entire mass of the atom is concentrated in the nucleus. That is. Then the next second one, the nucleus is surrounded by what? That is what we used to say orbits, understanding. So that is what a negatively charged electrons are present. So these electrons are constant position or continuously revolving, guys? They are continuously revolving in the orbits. That is what has been made. So electrons are not present at the stationary position. Always they will revolve around the nucleus in a circular path at very, very high speeds. Understand? So these circular paths only we used to call as energy cells. Also we can call it as what, guys? Energy cells. Also we can call it as orbits. What we used to call? Orbits we used to say. Understand? Darun, Elamokil?
Yes, sir.
Yes. So now
Yes,
this
sir.
is what we used to call as. Ma call to Shruti, please, somebody. Yes. So now if you notice it, next one. So what is the electrostatic attraction? So always you can see. So as we know, atoms are stable in nature. Yes or no, guys? But this is not the explanation given by Rutherford. That is what we used to study. Drawbacks of Rutherford we'll study now a little bit after. So now if you see here, the attraction between this positively charged nucleus and negatively charged nucleus will hold the atom together, because the number of positives and number of negatives are equal or different in every atom. In
Equal.
every atom. In every atom, the amount of positive charge is equals to amount of negative. So that is why the atom holds together both. Understanding? So because both are equal and opposite charge, so that is why the charged electrons holds the atom together. Because from the center, the force of attraction is acting on these electrons. So that is why these electrons are not moving away from the orbits. So next one. So these atoms is electrically neutral because the number of protons and electrons in an atom is every atom it is equal. So that is why we can say every atom is electrically neutral. And as we know, most of the positive rays will passing across the gold foil, so that we can say most of the atom is what, guys? Most of the atom is having empty space. So these are the 5 things which we used to call as what we used to call Rutherford model of the atom. So now if you notice it here, the structure of some atoms on the basis of the Rutherford atom. For example, if you take hydrogen, is it possible to represent with the help of this one? Because hydrogen atom, is it contains any neutrons? Is it contains any neutrons? No, we cannot say. So that is what. So hydrogen atom, basic hydrogen having only one proton and one electron. So that we can say the structure of hydrogen atom. If they will ask you how you can draw the structure of hydrogen atom according to the Rutherford. So it is positive charge P plus, and in cell who will be revolving, guys? Who will be revolving in cell? So that is what in cell it is revolving to electrons are revolving. So you can say E minus. This is what hydrogen, the electron, the structure of hydrogen atom. So we can say P plus is proton, E minus is electron. So that is what we used to call as nucleus. For example, if you take any other element, let me take. Now, for example, if you take lithium. So lithium, how many it is? Can anyone say? Lithium, if you take, for example. So lithium, what it is? Atomic number is 3. Yeah. So it is having what? So lithium, if you take, it is having how many protons? It is having 3 protons plus 3 neutrons, and it is having 3 electrons. So let me take 3 electrons in a single one. So later you can notice it because you don't know how to write the electronic configuration. Correct? Yes, okay, Ashita. Okay, so now this is what the lithium electron dot structure. You can say 2 electrons are in one shell and another one more electron is in another shell. This is what we used to say E minus, and E minus. Okay, so this is what we used to say electron. So like this, we can represent the electron, the structure of any kind of atom with the help of what? With the help of Rutherford model. But if you take here, Rutherford, as we know, the number of protons and number of electrons are how many, guys? Number of protons and number of electrons. So the number of electrons which are always equals to number of protons in any atom. So that's why the atom is always stable in nature. But here, if you notice it, for example, let me imagine I am standing in the middle. You all people are there. So let us understand the phenomena. For example, as we know, inside the atom who is present in constant position, protons are present in the constant position. Yes or no, guys? Please respond. Now,
Yes,
you people are revolving around me. Imagine I am the positive and you people are negative charge. Now you all people are following me in a particular orbits or energy cells. Now, if you are continuously in position, as we know, if you are continuously in position, circular motion, what is that? Every time the acceleration is keep on increases. Yes or no? Will you accept it or not? Always
Yes,
radiation, correct or not? Always it is in acceleration motion. So that continuously if you are revolving, what will happen, guys? For example, I will ask you to revolve. Is it possible to revolve continuously for the throughout the life?
No, sir.
No. For a certain period of time, you people will fall down. Yes or no? Because your energy will be over. Yes. So while you are in a circular motion, continuously the energy will be radiating, so that we will lose our energy. Yes, Karthik, Aswita, you understand? So now, so finally, when the electrons are revolving in these cells in a circular path, continuously when they are radiating energy, finally they will fall into the nucleus. Yes or no? Because They are holding. If you notice it here, what is the fourth point? The electrostatic attraction means from the center, from the nucleus, the positively charged nucleus and negatively charged electrons hold the atom together with the help of force of attraction, which is acting from the center of the atom. So now, if the electrons are revolving continuously, then finally they should always radiating energy, loss of energy, loss of energy, loss of energy. Finally, they should fall into the nucleus. Yes or no? Yes.
Yes, sir.
It is not happening in the case of atoms. So in the case of electrons. So that is what we used to say, drawback of Rutherford model of the atom. So Rutherford, he has been said inside nucleus is present, outside electrons are revolving and all. But he is unable to explain the stability of the atom. That is the biggest drawback of Rutherford model of the atom. He is unable to explain the stability of the atom. So because whenever the electrons are revolving in a continuously circular motion, they should lose the energy. That is what radiating energy continuously. Finally, they should fall into the nucleus. But it is not happening. So these electrons do not fall into the nucleus of an atom. So that is why they are very stable and they do not collapse on their own also. So but this Rutherford model, that does not explain the stability of the atom. That is why it is becoming drawback of Rutherford atomic model. So please all of you keep heading. Drawback of Rutherford model of the atom. Drawback of Rutherford model of the atom. Drawback of Rutherford model of the atom. What is the drawback? Manish? What is the drawback, Darun? You can draw this picture also. So this is what we used to say, drawback of Rutherford atomic model. So you might be imagining here. So when a continuously electron is revolving around the nucleus, so continuously it will radiate the energy. Finally, it needs to fall into the nucleus, but it is not taking place. That is why we used to say, and he is unable to explain this, why it is not taking place. That is why we used to call this one as called as what, guys? We used to call it as drawbacks of Rutherford atomic model. So please write it. If a charged particle undergoes acceleration motion, if a charged particle undergoes accelerated motion, because circular motion is accelerated only, correct or not? That is,
yes,
charged particle undergoes accelerated motion, then it must radiate energy. It must radiate energy. That radiate energy only we used to call it as loss of energy. Loss energy. Radiate energy or loss energy continuously. If a charged particle undergoes accelerated motion, comma, then it must radiate energy. Then it must radiate energy. It must radiate energy or loss energy continuously. Loss energy continuously. Loss energy continuously. Loss energy continuously. Then the electrons will attracted more strongly by the, then the electrons are attracted more strongly by the, then the electrons are attracted more strongly by the positively charged nucleus. Positively charged nucleus. So suppose if I am attracting towards to me more and more, then what will happen, guys? You people will come close to me, or you people will move far away from me. Suppose we both are fighting. Let me imagine two persons are fighting. Now your energy is continuously decreasing. Now my energy, my force of attraction on you is more, keep on more and more, so that you will move towards to me, or you will move far away from me. If I'm keep
Far
on
away.
Towards
me or far away, if I'm keep on attracting you, what is happening? Towards, that is what? Understanding, that is. So more strongly, by the oppositely charged nucleus, by the oppositely charged nucleus, strongly by the oppositely charged nucleus, due to which they will come more and more close to the nucleus. They will come more and more close to the nucleus. They will come more and more close to the nucleus. And ultimately, where the electrons will fall, Maitreyan, Darun, where the electrons will fall? Ultimately, they will fall into the where? Finally, they will fall into the nucleus. That is, ultimately, they will fall into the nucleus. Ultimately, they will fall into the nucleus. Ultimately, they will fall into the nucleus. Ultimately, they will fall into the nucleus by taking the spiral path. By taking the spiral path. Now you can draw this diagram. You can draw this diagram down. When it is radiating energy, so they will slowly coming closer and closer and closer and closer to the nucleus. Finally, they should fall into the nucleus. But it is not happening. Yes or no? Yes. And finally, once the positive charge will fall into the negative charge is fall into the positive charge. Finally, atoms should collapse. But is it atoms are collapsing, guys? Atoms are not collapsing. No. So that is what he is unable to explain the stability of the atom. That is why it's become the drawback of Rutherford atomic model. So that is what you have to write it. So the last point. So this should make the atom very unstable. And this should make the atom very unstable. This should make the atom very unstable, and hence the atom should collapse. And the atom should collapse. Atom should collapse. So this is what we used to call, guys, drawback of Rutherford atomic model. What is this called as? Drawback of Rutherford atomic model. So when electrons are continuously radiating energy, like our spiral binding, understanding they should come and they should come and they should finally they will fall into the nucleus, so that atom should collapse. But this is not taking place in any kind of atom. So electrons are still continuously, even though they are always in a motion, still they are not losing the energy or not gaining the energy, and they are continuously revolving in a particular circular orbits. That is what it is unable to explain by Rutherford, why they are continuously revolving, why they are not falling towards to the center, because when they are in radiation acceleration motion, continuously they should lose the energy. But why it is not taking place, unable to explain by Rutherford. That is what we can say drawbacks or limitations of Rutherford atomic model. Is it okay, guys? Limitations, or else we can say drawbacks of Rutherford model of the atom. Clear, everyone? Now, for this drawback of Rutherford atomic model, our next scientist called as, what is his name? Niels Bohr. Understanding, Niels Bohr explained the stability of the atom. That is what we'll study now. So before going to study the Bohr's atomic model, or else Bohr's model of the atom, first of all, we should study what is the explanation given by Niels Bohr for the stability of the atom, or else the drawbacks of Rutherford atomic model. So please, all of you, write heading Niels Bohr explained, or else the explanation for the Rutherford's drawbacks of Rutherford atomic model. Explanation for the drawbacks of, Jayversan, are you there? Drawbacks of Rutherford atomic model. Okay, Rutherford model. So now, who has been given? Given by whom, guys? Given by, explained by Bohr. Okay, so Niels Bohr we can say, or we can say Bohr. So let us see what he has been said means. So as we know, electrons are revolving in where, guys? Around the nucleus. in a particular orbits. What is that orbits we used to call as energy levels, or else we can say shells. Yes or no? I told you, correct guys? So now each orbit having a different radius. That is what the first thing he has been made. So electrons in each orbit having a separate characteristics amount of energy, and these electrons which they are in orbits close to the nucleus having low energy, while the orbits which are far away from the nucleus have high energy. That is what Niels Bohr is explained. So he has said that the electrons revolve around the nucleus only in certain orbits. Understanding? So if you take any kind of nucleus, so nucleus contains positive charge. So these electrons are revolving in a particular orbits. So now each orbit having a different number of electrons, and a different orbit is having different level of energy. Do you understand, everyone? So this one is having different electrons, this one is having different electrons, this one is having different electron. So this is only we used to called as, what is this called as, guys? Energy levels. Understanding? Energy levels. So Rutherford said that, Niels Bohr said that each cell is having different energy, and the cells which are closer to the nucleus having low energy. Having what? Low energy. And the cells which are far away from the nucleus is having very, very high energy. So that is what he has been said, explained the first point for the drawbacks of Rutherford atomic model. So he said that the nucleus is present in middle, and the electrons revolving around the nucleus only in these certain orbits. So that is what we used to say energy level. So these electrons in each orbit is having same energy or different energy, guys? They're having a different amount of energy. So the orbits which are close to the nucleus having low energy, while the orbits having far away from the nucleus having higher energy. That is the first point said by the Niels Bohr, explained for the drawbacks of Rutherford atomic model. Next, second one. And what Rutherford unable to give the explanation, notice it, when their electrons are continuously revolving in a circular motion, they should radiate the energy. That is what it is in according to the Rutherford. Yes or no, guys? Please respond. So continuously in what? Continuously in radiation means loss of energy. Finally, they should fall into the what? They should fall into the nucleus. But further, he said, Niels Bohr said that yes, electrons are revolving continuously around the nucleus, but they are not radiating the energy. They are revolving with a fixed energy. Understanding? A fixed energy which is not losing during motion. Did you understand what I'm saying, guys? So that is the second point. He said that they are revolving in a particular orbit or particular energy level around the nucleus, and they are not radiate energy, or they not lose the energy. That is the explanation given by the Niels Bohr. So even though they are in accelerated motion around the nucleus, so the electrons do not lose the energy. So when they do not lose the energy, what will happen? If they are not lose the energy, what will happen? They will be continuously having a same